Notice if I play the animation back that the particles themselves are moving with the surface, however they aren't angling with the surface. They should be orienting themselves based on their location on the object, the grass object's normal. If we have a look at the surface normals on our grass object, you can see that they're all angled based on the rise and fall of the terrain, and we want our particles to follow those normals. So we can use the same information that we extracted from the get closest location node to get the closest location normal between our path and position. To do that, once again, I'm going to use a get data node, and at the location on my geometric grid, I'm going to get the point normal. That represents the points in my point cloud. You can see that the context of the get data node is already set when I plug the location into its source. We're actually looking at a location on this polygonal object, and I can find a lot of attributes. Point location, point normal in our case is the one that I want. And I want to take that normal angle and I want to convert it back into an orientation on the particle. So if we look under our rotation tools, rotation-based tools or orientation-based tools, we have a conversion node that allows us to convert direction to an orientation. And I want the point normal to align, the particle's point normal to align with the y up direction. So the normal is what I'm pointing at, and the up vector I'm using will be the positive y-axis. I'll convert that, so I've converted the direction, so I've converted a 3D vector to a rotation, which is giving me an x, y, z and an angle that I can rotate around, and now I'll set the particle orientation back on the ice tree. So I'll plug that into port 4. And if I play now, the particles are angling, except the next problem now is that they're obviously not orienting in the correct direction. So we'll solve that momentarily.